Dear students, today we are going to discuss about the topic Geometrical Isomerism. Second unit, Pharmaceutical Organic Chemistry III, second unit, fourth semester, Geometrical Isomerism. What do you mean by Geometrical Isomerism? Isomerism classified into two types, structural isomerism and stereoisomerism. Stereoisomerism classified into three types: geometrical isomerism, conformational isomerism, optical isomerism. Geometrical, conformational and optical isomerism. The optical isomerism and conformational isomerism is already discussed in previous classes, previous year. In this chapter, geometrical isomerism, in this unit we have discussed about the geometrical isomerism. Geometrical isomerism, in this chapter various topics are discussed: nomenclature of geometrical isomers, cis trans, EZ, syn anti-system. Second, method of determination of configuration of geometrical isomers, conformational isomerism in ethane, N-butane and cyclohexane, stereoisomerism in biphenyl compound, that's known as atropy isomerism. Then stereospecific and stereoselective reaction. These are the topics under the geometrical isomerism. Next topic, what do you mean geometrical isomerism? Geometrical isomerism, the isomers which are having same structural formula but differing in special arrangement of group or atoms around the double bond are termed as geometrical isomers. And this phenomenon termed as geometrical isomerism. What do you mean by geometrical isomerism? The isomers are having same structural formula but different in special arrangement of the group or atoms around the double bond. These are the isomers having same structural formula but a different arrangement, a special arrangement of atom or group of atom around the double bond. This termed as optical geometrical isomerism. This isomers known as geometrical isomers. Two isomers are not interconvertible due to restricted rotation of double bond. In this case, geometrical isomerism, two isomers or two forms are not interconvertible due to its restricted rotation around the double bond. Two forms of isomers are not interconvertible due to its restricted rotation of double bond. These are the examples of geometrical isomers. One example is 2-butene. In 2-butene, butene in the structure, 2-butene structure, IUPAC name 2-butene. So structure CH3, CH double bond CH, that is 2-butene. Okay. In 2-butene, two different special arrangement of methyl group. Double bond in 2-butene gives rise to following geometrical isomers. That is the two isomers, cis 2-butene and a trans 2-butene. The cis 2-butene is a, in case cis 2-butene, two methyl group, that is CH3, arranged in same side, that is known as cis isomer. Two methyl group, in this case cis isomer, two groups or atoms arranged on a same side, that is known as cis isomers. That's known as cis isomers. On opposite side, this is known as trans isomers. On opposite side, there are two methyl group. In case 2-butene, there is trans 2-butene that are also opposite side. But in case of cis 2-butene, two methyl groups are in the same side. These are the example of geometrical isomer. Second example, on 4-dimethyl cyclohexene. Two isomers, cis on 4-dimethyl cyclohexane and trans on 4-methyl cyclohexane. In case two methyl groups are arranged on same side, that's known as cis. But in case these are arranged on opposite side, therefore it's known as trans isomer. These are the example, two geometrical isomers, cis and trans on 4-dimethyl cyclohexane. Cis on 4-dimethyl cyclohexane and trans on methyl cyclohexane. Trans on 4-dimethyl cyclohexane. These are isomers not interconvertible. It is not possible to rotate double bond on the cyclohexane ring. Geometrical isomerism, the isomers are not interconvertible. But in case of optical isomers that are interconvertible, that can rotate the dextro and levo rotation is possible. Two isomers, dextro and levo rotation is possible in case of optical isomer. But in the case restricted rotation, in case not are interconvertible, this is not possible due to the rotate the bonds in the cyclohexane. Not possible to rotate the bond in cyclohexane ring. Therefore, it is due to the restriction about the rotation about the double bond. In optical isomerism, the rotation is possible, but in case of geometrical isomerism, there is restricted rotation around the double bond. Okay, understand? These are the two examples: 2-butene, cis and trans isomers, cis 2-butene and trans 2-butene, and also another example on 4-dimethyl cyclohexane. Next, reason for geometrical isomerism. What is the reason? Already relative, the atom or groups are attached on the double bond. They are fixed up because the hindered or restricted rotation about the double bond. Already known, their double bond, the restricted rotation around the double bond. Their rotation is not possible due to the restricted rotation around the double bond. There is hindered or restricted rotation about the double bond. Due to this reason, in this carbon-carbon double bond consists of one sigma bond and one pi bond. In case carbon-carbon double bond, they consist of one sigma bond and one pi bond. It consists of p orbital. P orbitals is there. P orbitals are perpendicular to the sigma bond. P orbitals are perpendicular to the sigma bond. It consists of carbon-carbon double bond. They consist of one sigma bond and one pi bond. The pi bond is formed by the sidewise overlapping. The pi bond is formed by sidewise overlapping of unhybridized p orbital of two carbon atom above and below the plane. These are the reasons. The carbon-carbon double bond consists of one sigma bond and one pi bond. The pi bond that is form a overlap. That is, the pi bond is formed by the sidewise overlapping of unhybridized p orbital of two carbon atom above and below the plane. Rotation through the CC bond, they form a overlapping. It is due to the restricted rotation around the double bond. You understand? The carbon-carbon double bond consists of one sigma bond and one pi bond. The pi bond is formed by the sidewise overlapping of unhybridized p orbital of two carbon atom above and below the plane. Of a bond. This is the rotation around the CC bond. Okay. Today we are going to discuss about the symbol of geometrical isomerism. What do you mean by geometrical isomerism? Geometrical isomerism. Example: types of geometrical isomerism: cis and trans isomers. That is geometrical. Two examples discussed: 2-butene and 1,4-dimethyl cyclohexane. Okay, these are geometrical isomers. Introduction about the geometrical isomers. Okay, thank you all.